My name is Gabrielle String, and on behalf of my colleagues, I will be presenting on research we're doing to look at the disinfection of surfaces to prevent SARS-CoV-2 transmission. Now, evidence is limited on the efficacy of disinfectants on surfaces relevant to elmic and humanitarian contexts. When we're thinking about surface disinfection, we can look at the organisms themselves that are of interest or surrogate organisms for enveloped, non-enveloped viruses and bacteria of concern. We can also look at different disinfecting agents that are available to our population of interest, such as soap and water, chlorine, or novel disinfectants, and how efficacious these are on both healthcare facility surfaces, but also more porous surfaces that we might find in households and community structures, such as wood and cloth material. And then lastly, the disinfection method can impact efficacy, and that would include whether or not we pre-clean a surface, the contact time for the disinfectant to be on the surface, and the application method of the disinfectant. Now, we're interested to understand, can we use a surrogate to complete this large framework of testing specifically for looking at SARS-CoV-2? So our study, we have conducted two frameworks of testing. The first was looking at chemical disinfection, when we utilized 4 organisms: SARS-CoV-2, another coronavirus known as MHV, which is a murine hepatitis virus, and then 2 bacteriophages, phi 6 and MS2. We applied those to 3 different surfaces: stainless steel, polypropylene plastic, and wood, and exposed them to 4 different concentrations of chlorine, ranging from 0.01% to 0.5%. The chlorine was on the surfaces for 30 seconds to 5 minutes before it was neutralized. And in total, this matrix resulted in 146 tests that were conducted in triplicate with positive and negative controls. We were also interested in how efficacious antimicrobial surfaces could be at inactivating SARS-CoV-2 and potential surrogates. And so for the same 4 organisms, we looked at copper and a novel hand washing material known as the super towel. And for this, we applied the organism directly to the surface and exposed it for anywhere from 1 to 15 minutes of drying time. And this resulted in 38 tests conducted again in triplicate with positive and negative controls. So if we look at the results for steel, for instance, the way we can read these graphs is that on the y-axis, we have the log TCID 50 units per milliliter or log PFU per milliliter for each of our organisms. Our coronaviruses are plotted as circles, with SARS-CoV-2 being a filled-in circle, MHV being an open circle, and our bacteriophages are plotted as triangles, with phi 6 being a filled-in triangle and MS2 being an open triangle. So we can see that for 0.01% NaOCl, we don't have much reduction in these organisms over the 5-minute exposure time. But when we increase the concentration to 0.05% NaOCl, we see that as the exposure time increases, our virus decreases, and as our chlorine concentration has increased, now our virus has decreased on the surface. And that's particularly true for MHV in this plot. And then as we increase to 0.1% NaOCl in black, you'll notice that the SARS-CoV-2 is being reduced to non-detect within 1 minute, and then at 0.5% NaOCl within 30 seconds, SARS-CoV-2 is reduced to non-detect. Now, the same trend holds true for plastic, where we see increased exposure time and increased chlorine concentration decreases the virus detected on the surfaces. And for wood, although I will note that on wood, you'll notice that as our chlorine concentration increased, we had a decrease of SARS-CoV-2, but not of the bacteriophages phi 6 and MS2. And then when looking at our antimicrobial surfaces, across the 15 minutes of exposure time, there wasn't much of a reduction in virus detected on the surface. And that held true for both the copper and the super towel surfaces. So in summary, SARS-CoV-2 was reduced greater than 4 log within 30 seconds of exposure to 0.5% NaOCl on both porous and non-porous surfaces. MHV was inactivated faster than SARS-CoV-2, which means it's not a conservative surrogate. And disinfection of the bacteriophages was challenging on wood, and copper and super towel were not efficacious within 15 minutes. Key takeaways is that chlorine is efficacious against contaminated porous and non-porous surfaces for SARS-CoV-2, and we would recommend using 0.5% NaOCl. The antimicrobial surfaces did not reduce viruses through contact killing after short exposure. NHV seems to be a poor surrogate for SARS-CoV-2, specifically for chlorine disinfection studies, and we propose the use of the bacteriophage phi 6. We need further research on a range of environmental conditions, antimicrobial surfaces in practical use instead of passively as tested in this study, and understanding the inactivation mechanism of chlorine for coronaviruses. With that, I'd like to thank our contributors and you for your attention today.